Hello everyone, welcome to Cypher Phase, and today we have a question number 2685, that is count the number of complete components. It is a medium level question and it is a graph question. Okay, so you are given an integer n. There is an undirected graph with n vertices numbered from 0 to n minus 1. You are given a 2D integer array edges. This is the vector that will store the edges from u to v, source to destination. Also, there exists an undirected edge connecting the vertices a and I, A and B. Return the number of complete connected components of the graph. A complete a connected component is a subgraph of a graph in which there exists a path between any two variables and no vertex in the subgraph shares an edge with a vertex outside the subgraph. A connected component is said to be complete if there exists an edge between every pair of its vertices. So let's take what is a complete graph. Suppose we have connected component. Okay, so suppose we have these three nodes. Then we can say that A should be connected to B, 1 is connected to 2, 2 is connected to 3, and 3 is connected to 1 as well. So this kind of graph are called a connected component or a connected graph. Okay, let's take another example. Suppose we have 5 nodes, 3, 4, 5. From 1 we should be able to go to 2, from 1 we should be able to go to 3, from 1 we should be able to go to 4, and from 1 we should be able to go to 5. Similarly, from 2 all other nodes we are able to visit, from 3 we should be able to visit all nodes, and from we should be able to visit all the number of nodes. So if there is a connected component or there is a connected graph or a connected component, then what should I want to say? That the number of edges in connected component is equals to number of nodes, that is n, multiplied by n minus 1. That is for these two 5. Let's take the example of this. For n equals to 5, here we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the number of edges. Here edges equals to 10. Now we will check using this formula. Keep 5 minus 1, that is equals to okay, I have not written the whole formula, I guess. Yeah, it should be divided by 2 as well. Okay, 5 into 4 divided by 2, that will give us 10. So these are the number of edges in a connected component. Now let's do something else. Well, I'm just telling you the concepts, but here we will do something else, and we will use BFS traversal to solve this question. Okay, so I'm just going directly to the coding part. Okay, here's the coding part, and I will explain the code. What I'll do, I will just first make the adjacency list So what I'll do, I'll make a vector of vector integer adjacency list with n nodes. Now I have to also use edges. Now using these edges I have to fill this adjacency list. So pushback e of 1. Similarly, it is an undirected, so we have to do the reverse thing as well, true. Okay, now I will create a vector bool for the visited nodes, and I will initialize the vector with false. Okay, and I will just have my answer equals to 0, and now I will iterate over all the nodes using this loop, and if visit of I, if we have already visited the node, then we will continue. Otherwise we will make a queue of integer, and there we will push all the nodes, not the first node I mean to say, and I will make it, yeah, we have visited this node, so I will mark it true. Thereafter I will count the number of nodes equals to 0, and also I need a degree sum, and initialize with 0, and now I will use this queue and try to iterate over its adjacent neighbors. So I will use this while loop. This is the starting point, so I'm just q dot front. Thereafter I've just popped the first element, and I will increase the number of nodes because we are adding a node, and I will write degree sum equals to plus equals to adjacent of u dot size. Okay, and now I will try to traverse over its adjacent nodes using this loop, and if we have already visited that node, not visited that node, we will visit that node, and if we have already visited, then no need to visit that node again. Okay, and I will push back the nodes we have not visited. At last I will write one condition that will say that if the degree sum is equals to nodes minus 1, this is the formula, then we for checking the connected components, then we will add the answer, increase the answer, increment the answer, and thereafter at last we will return the number of connected components in a particular graph. So this is how we will solve this question using BFS traversal. Here you can see the answer is accepted, and I hope you like the solution. Thank you.